What's up, guys? We're going to be talking about classes and object-oriented programming. Now, the idea behind object-oriented programming is that it's a different paradigm to what we refer to as procedural programming. Now, we're going to see examples of both in this session, and we're also going to define what we mean by a class in programming. Now, we had some code that we were working with before. We're actually going to comment out this code, but we may use it as a template. And we're going to explore two different types of programming. So we have procedural and we have object-oriented, or OOP for short. So object-oriented programming, or OOP. Now, procedural is the most intuitive way of writing code. It's simply having a step of different functions or statements to be implemented one after the other in code. So let's say we were creating an object in JavaScript, and it's going to be this object that describes a car. The most procedural way of doing this is, first of all, to define the object. And we can just specify that it's an empty object. We can then say myobj.name equals fiat, myobj.model equals 500, myobj.weight equals 850, and so on. In fact, let's just give it a color as well. So we have something that has four properties, myobject.color equals white. And if we were to console log that to the screen, let's see what we get. We simply get a representation of our object. So this is an example of procedural programming. Everything is executed in order. And finally, my object is printed out to the screen. Now let's say that we'd like another object which represents a different type of car. Let's say, for example, we want it to be a Ferrari. Well, we technically have to start writing out the same object again. We could probably just rename it in a few different ways. So if we paste this down here, we could maybe call this first one car1. And we could maybe call this second object car2. And then we start changing the details. Name is Ferrari. Not really sure what number we should put here. We'll just call it fast as the model name. And we'll assume it weighs a bit less. And we'll assume it's red. So what ends up happening here is for every single car, we have to create a new object. So that's problematic, especially when we have the power of programming. There's usually a faster way of doing this. And this is especially true if these cars share certain features. So imagine, for example, that by default, all of our cars have these features. So we'll actually, above everything, we'll create a new variable and we'll call it let default features. So imagine every single car in our garage has these features and we're going to pass in this particular object here. So what we'd have to do is we'd have to say car1.features equals and then pass in default features. Then we'd have to do the same for car2. Car2.features equals default features. So if we now console log out car1, then we see we get the object here, including the features, which is an object itself. But we don't necessarily want to type this out every single time because it's something that's unique to both of the cars. And there could be other properties as well that you would expect. For example, has wheels equals true. And obviously we expect all of our cars to have wheels really. Point is, it's something that's common to both of these. You can also console log out car2 as well here. So is there a way that we can increase our efficiency here? Well, the answer is yes. And this is where object-oriented programming comes in. So what we see is that these objects, they share the same properties, and some of the properties have the same values as each other. So this is where classes come in. A class is essentially a blueprint for an object. So let's see how this works. In object-oriented programming, we're going to create a new JavaScript class. So we'll say class car, and we'll put the details of this class inside curly brackets. The exact implementation of this will depend on the programming language, but most programming languages make use of what are known as constructor functions on classes. And JavaScript does that. So we'll have a constructor function inside this class, and it's going to be a function that's run when the class is first created into an object. You'll see how this works shortly. Let's create the constructor function first. So we're going to apply all of our default values to the car class, and then those default values will be passed on to any of the car objects we create from this default car class. So we're going to say this, and this refers to the class. We'll say this has wheels equals true. We'll say this dot features equals, and we'll reference our default features object variable. And now we're going to console log out the value of car. So we have a very basic JavaScript class. We can see it's actually listed as a function. Now let's create our class into a new object. So we'll say let fiat equals new car. Now let's console log out fiat. See what we get. So we can see the details of our fiat object here. See, it has the has wheels property. It has the features property. But also notice before the object, we have the class name car. In other words, we're being told here, this is an object that maps to the car blueprint class. If we try to console log out fiat has wheels, let's see what happens. We simply get true. The advantage of this is we can use the same class blueprint for all of our cars. So we can say let Ferrari equals new car. Let's also console log out Ferrari. So we now have two objects which are created from the same class and have the same default properties. But of course, we want to add some unique details to each of these newly created objects. So for example, we might say fiat.name equals fiat, and we might say Ferrari.name equals Ferrari. And you'll see that these are two distinct objects created from the same class. So you can see our first object created from the car class has the name fiat, whereas our second object created from the same car class has the name Ferrari. And we don't necessarily have to do this after creation. We can add these unique details in at the time of creation using that constructor function. So let's delete the addition of the name property. And in the constructor function, let's accept the parameter name. And we can say this.name equals name. So we take in the name of the vehicle at the time we create the object from the class, and we set the name of that vehicle to the name that's given at the time of the object creation. Let's see how that works. So we say let fiat equals new car, and then we pass the string fiat into the constructor function like so. Same for the Ferrari. And if we run this, we get the same results. So we get an object with the name fiat, which is based on the car class, and we get an object with the name Ferrari, which is also based on the same car class. It just has a different name property because a different parameter was passed to the constructor function of the car class. So as you can see, we can create as many different objects as we want to from the same car class, and we can assign a different name at creation by making use of what we refer to as a constructor function. And it doesn't just have to be the name. For example, we might find these cars have different colors. So let's pass in color as well as one of the params for the constructor function. And we can say this.color equals color. So now we can say fiat, and we can also pass in white as a second param, and we can pass in red as a second param for the Ferrari. Let's console log out both objects. So we see the first object has the color property set to white, whereas the Ferrari has the color property set to red. So let's add one final param to our constructor function, and that is going to be the make. So for the fiat, we're going to say 500. And for the Ferrari, let's just say classic. In the constructor function, we need to call this.make equals make. Let's console log out our objects. And now based on the fact that we have the name and the make, we can now implement this details function that we made use of previously. So let's just grab the code for this details method. It's going to return this name plus this model. Let's grab this. And it's really simple to add an additional method to our class. So we're going to call it details. Then we'll paste in our return value, which is this name plus this.model. Save that. And now what we can do is we can call fiat.details and we can call Ferrari.details. So these are built in. It's inherited this particular details method from the parent class, which is car. So let's run this. So you can see we've changed our syntax slightly. Instead of using make, we were originally using model. So let's just fix that bug with our code. Now let's rerun this. Fiat.details logs out Fiat 500 and Ferrari.details logs out Ferrari Classic. So you can see with the procedural version of things, we have to create the entire object from scratch every single time. It's a lot of extra work. It makes more sense intuitively, but now imagine we have 100,000 cars that we want to create objects for. Well, we don't want to be doing this manually for every single car. And if there are any default features that are common to all of the cars, then we want them to be included on the object by default. We can always overwrite that. We can always change the features on one of the vehicles, but if something's a very common default, then we should probably include that on our class itself. And then if we need to, we can change the value on the object that's created. But if we don't need to change it, we're just saving ourselves lines of code by including it as part of the default class. So if we want a third car, instead of having to do all of this again, we can very easily create a third car. So we can say let Ford equals new car. It's Ford. We'll say it's black. And we'll say it is Focus. And then we can immediately console log out Ford.details because it's inherited this method from the parent class. So you can see we get Ford Focus echoed out to the screen. So the key takeaway here is that this type of programming where we make heavy use of classes, it's referred to as object-oriented programming. We won't often just define a function. That function will instead be a method on an object. So if we want to access that particular function, we'll reference the object first and call the method on that object. Whereas the first type of programming that we saw, which admittedly is more intuitive, beginners often make use of procedural programming, but as they pick up more skills as a programmer, they generally end up transitioning over to a more object-oriented way of writing code. There are pros and cons to both. Some programmers do still swear by procedural programming, but the general consensus is that object-oriented code is more efficient. It's neater in the sense that we don't need to repeat lots of our code again and again, which is what can often happen if we're writing in a procedural style. So the general consensus here is that programmers should really, in most cases, be making use of object-oriented code.